Now, I could do a half an hour on this subject alone and put us all to sleep, but instead I want to touch on 4 high points about tires that I think you can keep on your mind as you go shopping for them. First thing to know is the big concept, which is your tire isn't this big blob of rubber. There's a lot of engineering going in here, a structure that is built to operate a certain way, not just hold air. And unlike just about any other part of your car, this one changes shape rather dramatically when it's working. That's an amazing thing to keep in mind as well. Now, the first concept is the contact patch, or the footprint. That's where this tread here sits and meets the asphalt, and it varies in width and length, if you will, kind of this way, depending on the tire design, pressure, and your car's weight. What happens at the contact patch is amazing. That footprint allows 3 major things to happen. First of all, for power to be applied to the road as the wheel is turning one way in relation to the car, and for braking to happen as the wheel is being resisted kind of in the opposite rotating direction in relation to the car. And then you've got the other 2 axes, which is kind of out and in laterally across the tire. That's how cornering happens, and you get that nice grip. And all of those dynamics typically will happen all at once or within a second of each other, and the tire's got to be able to deal with all of them well. The next thing that we all notice very much, and you should be aware of, is the profile of the tire, its height with relation to its width. Now, we love our low-profile tires. They look great on almost any kind of car. It's been a big trend the last few decades to get this sidewall lower in relation to the width of this tread. But what does that is the frame inside the tire. They're called the belts. They're made of either polyester or steel, and they don't just bring that profile down. When you do that, you change the nature of how the tire operates in 2 kinds of loads. One is radial load, the load that comes, if you will, kind of vertically down on the tread. The stiffer this is, that may change the ride comfort. You get more drumming in the car. You get less of a soft, compliant ride. And this low-profile tire also has a very different behavioral for lateral loads, which is sort of this side-to-side load. Think of it as a cornering load for the most part. This low-profile sidewall is stiffer. The tire's going to kind of scoosh less left to right as you go in and out of a corner. That's great for performance, but that can also harshen up your ride because there's less give in this overall design. It's a trade-off between that sharp performance and that comfortable, compliant ride quality. And then, of course, there's the tread itself, that actual intricate pattern that we all know and see on the face of the tire. This isn't just here as a random pattern or to look cool. The ideal tire, to be honest, has no tread. If you're driving in perfect conditions on a dry piece of pavement on a summer day, like this slick right here, it puts the maximum amount of rubber on a dry, clean, smooth piece of pavement. But that's not the real world. So our tires on passenger cars do have tread. We drive on roads that have gravel, that have snow, that have rain. So your tread is designed to deal with all those, to work its way around gravel and find the traction between the actual rocks, to get down in snow and find some grip in that material, or on a rainy day to take the water in the middle of the tread as you race down the street and evacuate it out the side. Otherwise, you end up flying on the surface of the rain. That's called hydroplaning, and that's no fun. And 2 other factors about tread design. The way that it grips and then releases the road is a key part of how well this thing does in corners. Is it going to create oversteer or understeer? All tires have some slip as they turn, but the nature of that allows the car maker to dial in the cornering behavior they want in their overall vehicle. And finally, tread has a lot to do with quietness of a tire. The way these lugs grip and release at the road creates more or less and varying kinds of sound. That's where all the road noise you hear from tires comes from, and that's a big deal on luxury cars in a different way than on sports cars. The last thing I want to bring to your attention is rolling resistance. What it takes for this tire to roll down the road varies dramatically by its design. The really grippy, wide, sticky tire is going to be great at cornering, accelerating, and braking, but perhaps require more energy just to keep the car moving at a set speed, let alone to accelerate it. And that's not a good guy in an era when automakers are looking everywhere to save even a few drops of gas per mile. Now, it used to be that low rolling resistance tires, which you'll find on many very high efficiency cars, were awful. They were like having a 3-day-old bagel mounted on each wheel. Now, they tend to be pretty decent performance tires. Not extreme, but acceptable. They're much better at having a quiet ride, pretty good performance, and actually looking good as well. Oh, by the way, if you want to know what all this stuff on the side of the tire means, it calls out much of the technology within it, and we did a separate piece on this a little while ago about how to read your sidewalls. It's important for the tires you've got, but especially for the ones you're considering buying. I'll put a link into our episode 64 show notes to take you right to that piece, and that's at cnetoncars.com.
More Car Tech demystified right now at cnetoncars.com. Click on Car Tech 101.